Good day, students. So in this clip, we're going to be going over how to graph asymptotic trig functions. We're going to be graphing secant and cosecant curves in this installment. All right, so let's go ahead and write out the instruction for the examples we're going to do. So graph the specified um, trig function on the given domain and analyze completely. Okay, so basically indicate where it's increasing, decreasing, maximum, concavity, and points of inflection where applicable. All right, so for question number 1, we're going to be graphing y equals secant x on the domain 0 to 2 pi. Okay? All right, so whenever we're graphing um, asymptotic trig functions, the first question we ask ourselves is where are the asymptotes? Okay, so where are the asymptotes for the secant function? So we need to express secant function as a reciprocal identity, um, and that will tell us where the asymptotes are at. Okay, so uh, y equals secant x is equal to 1 over sine x. I'm sorry, 1 over cosine x. Okay, 1 over cosine x. So what does this mean? This means that the asymptotes occur when cosine x is 0. Why is that? Because when cosine x is 0, we're going to be dividing by 0, which results in an asymptote. Okay, so in order for us to generate this graphically, we're going to graph the cosine function first, use it to generate our asymptote, and then use the reflection of the cosine function to get the secant curve. All right, so we're going from 0 to 2 pi. So let's go ahead and set up our coordinate system. It's clearly in the fourth and first quadrants. So we can draw it like this. Exaggerate the positive side of our x-axis. So let's see, this is our um, x-axis and this is our y-axis. Okay, so what we are drawing in this case is we're drawing the cosine curve first. Okay, so let's make this a little bit bigger. Yeah, we can just do it like this. So we're going to draw our cosine curve first and then use it to draw our secant curve. All right, so calibrate, we're going to use, let 4 tick marks be 2 pi. So 1, 2, 3, 4. So that's 2 pi right there. And in the center, that's pi. This is pi over 2, and then that's 3 pi over 2. All right, so let's use 3 tick marks for 1 and -1 because we're graphing y equals cosine x. Okay, so now how do we graph y equals cosine x? So let me indicate that right here. Graph y equals cosine x. So remember that cosine x are like the cups. So let's go ahead and put the points that define the cosine curve. So we start from the max on the y-axis, max, center, mean, center, and then max. Okay, to make sure we got this correctly, let me add on the max and the min so we can have a good visual. So there goes the max, and right there goes the min. Okay, all right. Now we're going to go ahead and draw the cosine curve. Now, since the question asks for secant, not cosine, when we're graphing the cosine curve, we're going to make it a dotted line so that we can clearly see that that's not the answer we're looking for. So there goes the cosine curve in dotted form. So dot, 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 that, dot, 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 dot. This is the cosine curve on the domain that we're supposed to graph secant on, from 0 to 2 pi. Okay? Now, why did I graph this? It tells me where the asymptotes are. So let's go ahead and graph the asymptotes. Okay? There's a broken line here. So the asymptotes are wherever x is cosine is 0, so it happens right here. So you have one asymptote there, and then you have another asymptote right here. Okay, so there goes your asymptotes. Now, to graph the um, secant curve, we're just simply going to draw a curve like this. It's like similar to a reflection of this, but it gets close to the asymptotes without touching it. So you draw a curve like that, going up. And then on this piece right here, you flip it downwards, and then you have a curve going like this, and then a curve going like that. You get close to the asymptote, but you don't touch it, and then you reflect this going up. Okay, so this is the graph of secant x. All right, so you can erase the cosine function that you drew just to show what the secant curve is. So you can erase that. It doesn't have to be there. That was just to guide the construction of your secant function. Okay, so there goes y equals secant x from 0 to 2 pi. Okay, all right, let me put the other pieces of information. Right here, this is pi over 2, and this is 3 pi over 2. Okay, all right, now let's find out some information about this curve. Where is it increasing? Where is the curve increasing? You can see that it's increasing from pi over 2, I'm sorry, from 0 to pi over 2, you see it's going up. And then it's also increasing from pi over 2 to pi, but there's a break in the center. So we're going to say it's increasing from, this is, if we look at, it has an open circle, so this is going to be open also. So this point, the beginning point right here, is going to be an open circle since cosine was open at that point. And also at the terminal point, we also have an open circle because cosine was not included, hence we cannot include our secant. Okay, so this is also an open circle. All right, because at the end you have open circle here, and then you have open circle there. Okay, so for increasing, it's increasing from 0 to pi over 2, and then it took a jump to the bottom here, and then increase again, union from pi over 2 all the way to pi. Okay, you can see that it's going up, up, up over here, and it's going up, up, up over here also. Now, where is it decreasing? Where is it going down? It's decreasing from pi all the way to 3 pi over 2. You see it's going down, down, down here. So from pi all the way to 3 pi over 2. And then also decreasing from 3 pi over 2, union 3 pi over 2, all the way to 2 pi. We have to break it apart because in the graph there are breaks there. Okay, so just to illustrate for you, you can see how it's going down, down, down on this interval, and also it's going down, down, down. So that's why it's decreasing here and decreasing here. On the other side, it's increasing, it's going up, 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 and then here it's also going up, up, up. So this is increasing, and then that's decreasing. All right. Okay, so we have the increasing and decreasing down. Now, let's look for the max and the min. Well, for the secant function, how high does it go? It gets infinitely close to this asymptote, and it goes up forever in this graph we just drew. So in this case, since this goes up forever and this piece also goes up forever, we have no maximum, none. All right, how about our minimum? How low does this graph go? Now let's look at this piece because it's the one that goes down. This piece goes infinitely low, but it gets really close to this asymptote, never touches. So no matter how low you go, it keeps getting closer and closer, but never touches, but it keeps getting smaller. Okay, so the minimum actually is none because it goes down forever. So there's no max and there's no min. Concave up. Concave up, where do we have a complete U or a partial U? From the left or from the right. Okay, if you take a look at this curve, you see that we have a complete U facing down here, and then you have a partial U facing up here, you have a partial U facing up here. So it's concave up on the from 0 to pi over 2, and then it's also concave up from 3 pi over 2 all the way to 2 pi. Okay, concave down, where is the U facing down either partially or completely. From pi over 2 to 3 pi over 2, we have it facing down. So from pi over 2 all the way to 3 pi over 2. Okay? All right, point of inflection. Inflection. Now, where does the concavity change? Concavity changes at pi over 2 and 3 pi over 2, but there's a jump. There's a big jump here. This line is not part of the graph, so we cannot add it. Okay? So since there's no line on the curve where the concavity changes, there's basically none. Okay, so basically anytime the points of inflection are excluded from the graph, we cannot consider them as a point on the graph. All right, so there are no points of inflection on this graph. All right. All right, now let's take a look at question number 2. For question 2, we're going to be graphing, considering the curve. We're going to be graphing y equals cosecant x on the interval negative pi, from negative pi all the way to 3 pi over 2. Okay, all the way to 3 pi over 2 included. All right, so first thing we want to ask ourselves is, since this is an asymptotic trig function, where is the asymptote going to be? So y equals cosecant x. How can we express this using our reciprocal identity? Cosecant x is equal to 1 over sine x. Okay, so what does this tell me? It tells me that we have asymptotes. The asymptotes occur. The asymptotes occur when sine x equals 0. Okay, that's when the asymptotes occur. Okay, so what we're going to do first is we're going to graph sine x on this interval, and then use it to find the asymptotes. All right, so let's go ahead and construct our coordinate system. So there goes my y-axis. Change my line style here. It's solid. Okay, so there goes my y-axis and my x-axis. Let's go ahead and draw that. And then my x-axis. Okay, and now we're going to calibrate our coordinate system. Let's use 2 ticks for pi over 2. So this is negative pi over 2, and then this is negative pi. And then this is positive pi over 2, positive pi, positive 3 pi over 2. Okay, and then this is 3 marks. This is 1 for your max. And then go down 1, 2, 3. That's negative 1. The reason why we're using 1 here is because there's a 1 in front of cosecant, and also our sine, there's a 1 in front here. So that means our amplitude is going to be 1 also. Okay? All right, now let's go ahead and sketch our max and min. So this is the max. Just make it a dotted line. Okay, let's change that. All right, and then our min will go from negative pi all the way to 3 pi over 2. Okay, so what we're graphing is sine x to help us find the asymptote. So let's go ahead and graph sine x. Remember what the sine function, the sine curve looks like, is like an S starting from the center on the y-axis. So this is my y-axis right here, and this is my x-axis. So let's go ahead and graph it. So starting from the center, you go center to the right, you go up since it's positive, center max, center min. Okay? This is going to be a closed circle because you have a bracket right there. And then to the left, center, min, back to the center. This would be an open circle. All right, let's go ahead and draw the sine. But remember, this question is asking for the cosecant and not sine. So we're going to use a dotted line, okay? So dot, dot, dot. This is the sine that's going to guide my construction of the cosecant curve. So there goes the sine. Okay, now, we're now going to graph the asymptotes, okay? Alright, asymptotes, it happens anytime sine is equal to 0. So let's go ahead and graph that. In this problem we have an asymptote right here. We have another asymptote on the y-axis. And then we have an asymptote right here. Okay? Alright, now let's go ahead and draw the secant curve. The secant curve is exactly like the sine curve. I mean, it's just like the same procedure as we did for the secant curve. Okay, we just flip it up. Alright, so for this piece right here, we'll flip it downwards. Go real close to the asymptote, but you don't touch it. And then this one also, starting from that point, you flip it downwards, like that. And then this, you flip it upwards, go close to the asymptotes without touching it. And then this, you flip it upwards also, close to the asymptotes without touching it. And then the last piece right here, you have a closed circle. And then you go close to the asymptote, like that without touching it. Alright? Okay. Now, let's do our analysis, indicate where it's increasing, decreasing, max, and min. Alright, so for this one, where is it increasing? Where is it going up? Alright, it's increasing. We can see that it's increasing here. It's going up, up here. And then it's also going up here. And it's also going up here. Okay? So where is it increasing on those three intervals, right? So from open circle, negative pi, all the way to negative pi over 2. That's the first one. And then union, pi over 2, all the way to pi. And then we have an asymptote there, so we have to jump union pi all the way to 3 pi over 2. So that's where it's increasing. All right, where is it decreasing? Where is it going down? Where is it heading downwards? Let's go ahead and indicate that. We'll notice it's going down here, down, down, down. And then it's going down here also, down, down. And that's basically where it's decreasing on those two intervals. So it's decreasing from negative pi over 2 to 0. Union, 0, because of the jump, we have to jump in our parentheses, 0 to pi over 2. Okay, so there is where it's decreasing. Now, maximum. How high does the graph go? Maximum. We're going to focus on this piece here. Well, what happens here? We have an asymptote, that means this keeps going up forever and gets really close, but it keeps going high forever, okay? Likewise, this piece. So since it goes up forever, the maximum is none. How about the minimum? Minimum. How low does this graph go? Look at this piece and this piece. This goes down forever. This keeps going down forever. This piece also. So we have no minimum. All right. Okay. Concave up. Where does the U open up? Partially or completely? It opens up right here. This is the only place that's concave up. So it's concave up from 0 to pi. All right. And then concave down. Concave down is we have U, a complete U or partial U facing downwards. We have a complete U facing downwards here. So from negative pi to 0, union. And then this other piece from pi to 3 pi over 2. Okay, so that's where it's concave down. Now, points of inflection, you notice where concavity changes. We have asymptotes. They have breaks there. So for inflection, we have none, because the points where the inflection changes we have breaks happening there. Okay, so there you have it. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. You can click like if you like this clip, and please post the comments to let me know what you think about this presentation. More clips coming from chef.com. Thanks again and have a wonderful day.